Okay, last question. A few different ways you could have done this. Some done well, some not so well, so let's have a quick look. So, first bit, the magnitude of the acceleration. So if you read through this, you've got a vehicle goes down a straight horizontal road, passes point A with a speed of 10. It accelerates for 21 seconds until it gets to a speed of 24 meters per second. It then travels at constant speed before decelerating at a uniform rate, coming to rest at point B. Now someone actually did a graph. Well, you can see you've got to do velocity time graph in part C. Someone actually did it to start with, and they did really well because they thought about what was going on. If I just really roughly sketch it, I'm not going to do it properly for a bit, but it starts at 10, it accelerates until it gets to speed 24. That takes it 21 seconds. It then travels at some constant speed and then decelerates to rest. Okay, and it says that it takes 16 seconds for that last bit. We don't know how long that bit is, but we can see this is the section. So we've got three things: an acceleration phase, constant velocity phase, and a deceleration phase. We're looking at the acceleration phase. So in the acceleration phase, we've got initial velocity 10, final velocity 24. Time is 21 seconds, and we need to find the acceleration. Only one equation for that: v equals u plus at. 24 equals 10 plus 21 times a gives you 14 equals 21a. 14 over 21 is a, which is 2/3, or some of you turned it to a disgusting decimal, 0.67 meters per second squared. Part B, it says determine the distance taken for the vehicle to decelerate to rest. Okay. So the deceleration bit is this last section of the journey. So we're looking at the deceleration part. Initial velocity on that deceleration part starts from 24 and it comes to rest. So it starts from 24, it comes to rest. The time taken, it said in the question, was 16. Go back up, you can just about see it, 16. And we want to know the distance that it's got to. So those four, you should know all of these. As equals half uv, blah blah blah. So the distance is going to be a half 24 plus nothing times 16. So whichever way you want to work that out, half times 24 times 16, you've got a calculator, comes out to be 192 meters. Okay. Right, the next bit, sketch the velocity time graph. So let's just find a little bit of paper. Sketch that velocity time graph. So we've just got to do it a bit more prettily, a bit more accurate. So nothing's really changed from what we talked about before. Well, nothing has changed. We know it goes from 10 to 21, okay, sorry, to 24, and that takes 21 seconds. It then stays at a constant speed, and we don't know how long that is for. We just told it's t seconds. That's not t here, that's not that figure, it's the gap between there and there is t. So if you wanted to label that, it's 21 plus t. Okay, after that time it decelerates to rest, okay, and that bit there takes it 16 seconds. So 21 plus the 16 means it's 37 plus t. Okay, that's what your sketch would look like. T in seconds, velocity in meters per second. Okay, what I'd really like is that all drawn properly, proper scales along here. Can't really use a scale for these bits because it's going to be a bit tricky, but they could vaguely be in proportion. But that's the key shapes and features you should have. Some of them not too good. So given that the distance, last bit of the question, you can still see it, given the distance between A and B is 15,000 meters, find the value of t. So distance, remember, is total area. A couple of ways you could do this. You've got several shapes to put together. Doesn't matter what order you do them in. It doesn't matter. So I'm going to look at shape A, shape B, and shape C. So shape A, let's just figure that out to start with, is a trapezium. So half the sum of the two parallel sides, sum the gap between them. Figure that out. So half times 34 times 21. We'll work that out in a sec. Area B, I don't know how wide that is. It's just t wide. And it's 24 high because it's a rectangle, it's 24t, that's okay. Remember, I'm trying to figure out t. Sorry, you can see that. T times 24 is 24t, can't figure that out. And then C, is triangle, half base times height, so it's half 16 times 24. Figure that one out. Just grab your calculator, stick those numbers in, and they are, off the top of my head, just going to grab my answer sheet. This one is 357. That one I can't change. 8 times 24 is 192. Remember this bit, you don't necessarily need to rework it out again, did I? Because it was in part B of the question. Okay, so total area 357 plus the 24t plus the 192 equals the 15,000. Solve that. Okay, take away the 357 from both sides. 14451. Divide by 24. You get a not very nice number. 602.125 seconds. So it stays at that constant velocity for a really long time, because remember t, the value of t was how long it was at this constant speed, stays at that t for 600 seconds. So actually this graph is completely kind of off scale, if you like, because that should be a lot wider, because that's only 21 seconds, that's only 16 seconds. You've just worked out that that is 602 seconds in terms of the width, so it should be much longer.